The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to today's presentation sponsored by Seal Aftermarket Products. We'd like to thank Seal Aftermarket for making the webinars available to everyone, members and non-members of ATRA. We would like to play you a short video on their products.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and ATRA transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda ATRA kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments, please send emails to webinars@atra.com. Any questions that you may have during the webinar, please feel free to text them to me and I will try to answer them the best that I can. This is the webinar schedule that we have for the rest of the year. The next one we will be doing on May 19th and 20th. That's on the Lineartronic CVT found in the Subarus. We are going to hold the expo at the same hotel in Las Vegas, the Rio that we held it there last year. The dates are going to be October 29th through November 1st, which is Halloween weekend. This is the schedule throughout the country for the seminars that we have across the country that we do the regular yearly seminars. Today's presentation will be the introduction to the ZF9HP48, or as Chrysler calls it, the 948TE. There's been some corrections to the next slide compared to your handout. The information in your handout on vehicle application I derived from most of my normal resources, which I found later on that were incorrect. The correction page will be shown next. What you need to do, if you look at your screen in the upper right corner, you'll see a camera icon that I have the red arrow pointing to. When the next screen comes up, just click on that icon. It'll take a snapshot of the screen and it'll save it as a JPEG or a photo file right there on your desktop. What you see here in red was a correction sent to me by Alan McAvoy. I would like to thank him for giving me this information. He works for Fiat Chrysler Automobiles, and there were some corrections as far as the Chrysler, Jeep, and Fiat as far as the applications. The Land Rover on the upper right, I removed the rear-wheel drive ZF 9-speed from that information. So if you want to go to the upper right corner of your screen, click on that little camera icon. It'll save this page right there on your desktop. If you didn't have enough time to do it, I can place this same screen up at the end of the webinar to give you guys more of a chance to go ahead and take a snapshot of it. Transmission identification is kind of important. The Chrysler is referred to as the 948T, is built here in the U.S. in Kokomo, Indiana. The ZF9HP48 is built in Germany. Externally, the two units look very similar. They look almost the same, but the parts cannot be interchanged. The VIN number will always use as a key to find the correct parts, especially when you use the dealer to replace any parts. You're going to need the VIN number for that. The barcode label, as you can see in the upper right corner, will identify which manufacturer that you actually have in your shop. This is a 9-speed front-wheel drive, 480 newton-meters of torque, or 345 foot-pounds. It's transverse, so it's a front-wheel drive, electronically controlled, and it has hydraulics and planetaries. ZF first developed this 9-speed right around June 2011, but it did not make its debut until mid-2013. This transmission delivers extremely short shift times and exceptionally smooth shifts. The electronic control select the right gear for the driving conditions. This eliminates any unnecessary stepping or constant shifting up or down. It uses the software with 40 different shift maps. This transmission also has the stop-start feature without the additional oil pump that we normally find on other vehicles with stop-start feature. Once this vehicle restarts, there's only one friction element that needs to be applied, and the response time is pretty fast as far as applying that clutch. This unit can also be used in hybrid vehicles. Obviously, the torque converter would be replaced with an electric motor. This transmission is also designed to have an additional transfer case so we can have all-wheel drive. Some systems you can decouple the all-wheel drive, which basically turns off the clutch and the differential that controls the rear wheels. As I mentioned before, ZF calls this transmission the ZF9HP48, and Chrysler builds their own, and they call it the 948TE. In normal driving, the transmission will start out in second gear, but it can be manually shifted with shift paddles, as you can see here on the steering wheel. You get more of a quicker acceleration at a low range of about 4.7 to 1. This is mostly used for off-road driving, especially in Jeep vehicles. Transmission also features what's called a skip shift feature. It allows it to downshift directly without hitting every gear, so it can actually downshift from 9 to 5 or from 5 back down to 3. It doesn't have to downshift through every gear coming to a stop. Obviously, the shift times and firmness of the shifts are all based on the driver input. This is a cutaway view of the unit. As you can see, we have several clutch frictions, and we also have what's referred to as the dog clutch A and dog clutch F. This is pretty unique to this transmission. We'll talk a little bit more about the dog clutches as we go through the webinar. This is a side cutaway view. I want you to notice that the A dog clutch and the F dog clutch do not use any friction plates. We have several other friction plates in it. The B clutch, driving clutch frictions. We have the C clutch, which is holding clutch. The D clutch is also a holding clutch. And the E clutch is a driving clutch. When we look at the clutch apply chart, as you can see, the A dog clutch in the first column is a driving clutch. It's on from 1st through 7th. It's delayed applied during rock cycle, or like when a vehicle is trying to be rocked out of mud or snow. All the way over to the right is the F dog clutch, which is a braking clutch. And as you can see, that's on from park all the way through fourth. Neither one of these dog clutches have any friction material. Failsafe operation, we have a couple of different ways this could occur. If we have like in the first column, the 948T parked by wire, where there's no mechanical connection between the shifter and the actual park rod in the transmission. This one can actually default to neutral. Nothing uncommon here. We've seen the same situation with Allison's. Mercedes vehicles will do that, as well as Volkswagens. Now the park by cable, which is the second column, as you can see, one of the fail-safes here is the transmission will be in fourth gear or reverse. Now the A dog clutch is one of the two dog clutches. The dog clutches use hydraulic pressure to engage and disengage the actual spline teeth between the two components. Now this obviously provides a non-slipping connection that does not use any friction discs. The A dog clutch is a driving disc located at the rear of the trans, and it's actually part of the input shaft. And that clutch is on from first all the way through seventh. Now when the TCM calls for a shift that engages one of the dog clutches, a message will be sent to the PCM requesting the PCM to bring the engine to a certain RPM, whether it has to raise it to that certain RPM or lower it. Now the dog clutches on this 948 cannot be applied during downshifts without consideration of the difference between the speeds of the spline components. Since they don't have a disc-style clutch pack that can provide any slip to try to match the component speeds. So the transmission control module, as well as request an engine RPM to be brought to a certain speed, it can also have the engine command difference in whether it increases torque or decreases torque to allow speed matching of the two components. Now, as the engine RPM increases, the transmission may slip one or more of the multi-disc clutches until the components of the dog clutch are at the same speed. So not only is it going to change engine RPM, whether it increases or decreases torque, it could actually slip or apply more than one clutch to bring the two dog clutch components at the same speed so they can spline together without causing any grinding or any delay in the shifts. Now, since the A dog clutch is used in first but not in reverse, the TCM will go through what's called the transitional phase in such situations such as rocking the vehicle out of snow or mud. So the TCM will use other clutches to synchronize the speed of the dog clutch and the input shaft as the wheel speed transition changes from forward to reverse motion. This is a clearer view of where the dog clutch is located at the rear of the trans. As you can see in gray is the main shaft. The main shaft stays stationary, it does not move. What's colored in yellow is the actual dog clutch. And there's a pin that goes through that dog clutch to a piston inside the shaft, and it will allow that dog clutch to move to the left to engage into the gear in front of it. As you can see here, this is another picture of the dog clutch, and you can see to the left is the ring gear. That purple section in the middle is the teeth that will spline into the A dog clutch. This is the F dog clutch, which is the actual sun gear that you see colored in blue. That stays stationary. That's the single sun gear for the P3 and P4 Planet. This clutch, like I said before, this is a braking clutch. Here you can see the gear, the transfer gear on the left that's attached to the support. The yellow section inside the transfer gear, when oil pressure is applied to one of these two ports, will apply and release this yellow section, moving it to the right and back to the left. And that's how it will engage the splines into the gear. The transfer gear is also splined to the P4 planet. You see a cutaway here. There's our F dog clutch, which is the single sun gear to both planets. And as you can see, we're splined into the P4 planet carrier with the transfer gear. It has the other side of the dog clutch assembly in it. Let's talk a little bit about the A&F dog clutch hydraulics, get a little clearer view of how this actually works. This is the A dog clutch hydraulic apply circuit. As you can see here in yellow is our A dog clutch. That's the pin that you're looking at right here that goes right through it. Inside the shaft is a piston. At one of the shaft, they'll send hydraulic pressure to move the piston to the right, and that would actually engage it into the teeth of the ring gear in front of it. This will be the release circuit. Oil pressure will now come down through the shaft between a couple of sealing rings. It will travel down along the shaft and actually move the piston back. So the actual movement of the dog clutch is very short. It's not very much of a movement, as you can see here. And that will disengage the clutch from the ring gear. And this is the F dog clutch apply circuit. What you'll see here is the small section that's inside of the transfer gear has some sealing rings on it. There's also a couple of seals here, and we'll just bring hydraulic pressure in from the into the gear itself, and it'll move that small section of spline teeth right onto the F dog clutch to apply the clutch. This will be the release circuit. Like I mentioned before, there's a couple of seals here, so we have some hydraulic pressure coming in from the other side, and it'll actually move the spline teeth that you see here in yellow back away from the sun gear to disengage it. Now the Jeep 9-speed has been out only for a short period of time, but they've had a tremendous amount of problems with the shifts, a lot of customer complaints. There's a new software that covers about more than 100,000 different Jeep Cherokees to try to address some of these complaints. There's a reflash that only takes about 5 minutes to do. They're up to their third software upgrade. But even though it only takes 5 minutes to do the reset, it takes a good 78 minutes to actually drive the vehicle and make sure that it is shifting correctly. Now, not all the vehicles that are sold, the Cherokees that are sold, need the upgrade, but several of them out there do. There's been several complaints written into the Chrysler company. Customers complaining about one of the major complaints was while it's engaged in the highway, it actually downshifts to 8th gear. And the problem here is that the dog clutch, when it's applied in 9th gear, when the dog clutch is released or applied, what they're feeling is a dragging sensation, or pulls the vehicle down when it shifts to 9th gear. It seems to be a lot of load on the engine. When this happens, the computer will actually downshift to 8th gear. Now, one of the reflashes that I know of is actually eliminated 9th gear in the transmission. So you have a Jeep Cherokee with this problem. They may do a software upgrade to it and actually cause the transmission to become an 8-speed. There are two speed sensors, input and output sensor. They're on a single assembly, and they're located right there under the valve body. You can see we took the valve body off and swung it out of the way. It's on its separate plug. They both produce a 5-volt square wave, so they're Hall effect type sensors. The input speed sensor uses the E-clutch housing as a tone wheel, while the output speed sensor uses the transfer gear itself. And you have a small wire diagram to the right showing how that they actually work going to the TCM. The fluid temp sensor is actually part of the internal harness, as you can see here. You have to be careful when removing this harness and placing it back. As you can see, it kind of fits into a small pocket there. You don't want to get it caught on the edge of the valve body and and bolt this down and push it down and cause any cracks or problems there. It's real critical to make sure that we place it in the right spot and then go ahead and tighten down the bolts to it. It's also a 5-volt signal. That's a thermistor type sensor, like we've seen before. Obviously, as it gets hotter, the resistance becomes lower and pulls the voltage down. And you have a schematic to the right that shows that. There's 2 different range switch variations. One will be for the shift by wire, and the other one will be the shift by cable. Both are non-contact magnetic-based sensors. They work similar to a Hall effect. They're supplied with 5 volts. And what you'll see is that the sensor is actually located at the top of the transmission, and the shift linkage rod will come in, and there'll be a lever that comes off of it that sits right in between these two, in this pocket right here. You'll actually move this black piece back and forth, and that's how the signal gets sent to the TCM as far as what gear you've selected. There's a feature called electronic range select on some of the vehicles that have console shifters. And as you can see, we can pull the shifter down the drive, move it over to the left, and go forward and backwards with the shifter to actually manually control the upshifts and downshifts. When you're in this mode, you'll actually see the gear that's been commanded right here in the center of the console between the gauges. Since the dog clutch apply and release is so critical, they have a pressure sensor. It works off of 5 volts, and the pressure will change the signal to the TCM. So now the TCM can control the pressure to release and apply the dog clutches. Solenoid identification, we have 2 different types. Obviously, we'll have a 9-solenoid valve body for a park by cable. And then we'll have a 10-solenoid valve body with a mechanical park solenoid to control the park rod for the park by wire system. This is the solenoid apply chart. As you can see, we have a solenoid for each clutch, including the A dog clutch and the F dog clutch. So the A clutch solenoid will control the dog clutch from 1st through 7th, as well as the F dog clutch solenoid will control that clutch from park all the way through to 4th. There'll be a difference also in the valve bodies. The park by wire system very similar to the 845 RE. There's no mechanical connection between the shifter and the transmission. The park lock piston is used to control the position of the parking pole. And of course, the linkage is spring-loaded to default into park position if there's any problems. So this can also default to park. So there's your cutaway view for the lower valve body and the upper valve body on the park by wire system. If it does default to park, there is a way to manually release the park pole. This is if we need to put the transmission in neutral to move the vehicle with the engine off. As you can see here, there's a little cover located in the center console. We just flip that cover up, and you'll see a bright orange cord, and we'll pull on that cord to actually release the park rod so that we can move the vehicle. This is one of the first complaints that I've seen so far, and this is with the ATRA models using the park by wire system. They use a push button, as you can see on the right. You don't use an actual shifter. Now, you may push the park button, it may indicate park, but the vehicle still may roll away. So as of January 6, 2015, ATRA is notifying all the customers of a recall. I know that I've heard that some of the recalls, they've actually replaced the entire transmission, and some of them they're actually working on a software issue for this complaint. In the meantime, ATRA sent out a letter explaining to vehicles that have not been brought back yet for the recall to use the actual handbrake or the park brake when you have the vehicle sitting on an incline, or even when it's sitting anywhere, they just don't want it to roll. so you have to use the park brake. Chrysler vehicles use a knob instead of a actual push button. Not that this makes a very big difference. I think I've only heard of one issue where one of the Chrysler models didn't hold park. So we're not seeing it so much in the Chrysler vehicles as we are with the ATRAs. This is a park by cable. You can see the lower valve body to the right. And here's another good picture of the actual linkage. As you can see, the linkage rods comes in. There's that lever that sits on the black piece of the IMS, and we'll actually move that back and forth from the left to the right. And this is the upper valve body cutaway view for the park by cable system. And as you can see on this valve body, we actually have a manual valve. TCM locations. Now the TCM may have Chrysler or ZF markings on it. Both Chrysler and the Fiat part numbers will be right there on TCM itself. As you can see, they go into several different models, from Land Rover to Acura, Fiat, Chrysler. You may find the TCM located just above the differential, sort of at an angle on the side. For the most part, we find them bolted right to the very top of the transmission. Some of these transmissions will come with a cooler warmer, and some of the imports that I've seen, you'll actually have a separate warmer and a separate cooler for the transmission. There's a couple of photos here of the external components. There's our label on the top, our vent. Here's our manual shaft. We have a check plug located here by the diff. We have cool line connections on the lower left towards the front. There's our valve body cover. And you may actually find a hydraulic line going from the back cover, the back of the case, down over to the side. And then there's this hydraulic cover plate. If you remove this, what you'll see is several different worm tracks for oil circuits and a gasket to keep them separated. But you won't find any valves or anything in that location. And this is the bottom of the case. There's our drain plug. You can see that this is a all-wheel drive setup. It has a PTO flange, which is actually separate from the actual openings for the axles for the front-wheel drive. There are two separate fluid checks, different procedures. There's one for the 2.4 liter engine. This is a fill for life, so they don't feel that the transmission fluid should have a problem unless there's some type of a leak. There's a special dipstick tool. You have the tool number in your handout. We will need a capable scan tool or OE software on a laptop to check the fluid level, because it has to be checked at a certain temperature. As you can see here at the very bottom, the fluid temperature has to be above 50 degrees Celsius. Most of the charts that you will find will be in Celsius. And the dipstick tool will be marked in 5mm increments. And of course you have to follow this step by step. This is the rest of the steps for the 2.4 liter engine. As you can see, number 5, they want you to raise the vehicle, and then you have to remove the left front tire wheel assembly. Again, this would be a different procedure on the 3.2 and 3.6 vehicles. Same tool number. This is the chart. This chart will work actually for both vehicles, both the smaller and larger engines. And the rest of the procedure to put the tire assemblies and everything back after the fluid check has been made. Here's your fluid level fill table. As you can see here on the left column, the temperatures are in Celsius. You have the next column that shows the minimal level, and the normal level and maximum level. This is the fluid check for the 3.2 and the 3.6 liter. Notice here that we're going to repeat the same steps 1 through 4 as we were previously shown. The next step though on this one is different. We have to remove the engine cover. Same tool, use the same chart for the checks. That takes care of the larger engines. Now, the recommended fluid is the ZF8 9-speed fluid. It's filled for life. You have the part number there in the handout for the fluid. I suggest using the OE type fluid. There's a lot of problems with this transmission right now, whether it's in Chrysler or Acura's. If you go to carcomplaints.com, look up Jeeps, and you'll see that there are several problems working with this transmission. Now, the fluid color is a pale green. They also recommend not to use any leak dye if you're checking for a leak on this transmission. One of the other things you can see here is the filter is mounted internally. So the transmission would have to be removed and the bell housing would be taken off to get to the filter. Now, if anyone decides to try using some kind of a multi-purpose full synthetic fluid on this transmission, by all means go ahead and email me any of the results that you have, whether they're good or bad. Talk a little bit about the all-wheel drive system. There's 3 types. We have an active drive 1 all-wheel drive single speed. That's the first one you see in the second column. Then we have a 4-wheel drive 2-speed and also a 4-wheel drive 2-speed with a locking rear axle. Obviously, these will be found for vehicles that do a lot of off-road. This is look at the selector, the dial selector that you have for the active drive 1 at the single speed, and it determines how the all-wheel drive will work, whether the differential module will be actually applied or the clutch will be applied there to activate the rear wheels in a slip condition. This is a layout of the transmission. You can see the PTU in the upper right at the single speed, and then you have your rear driveline module in the back. This is the 2-speed power transfer unit, and it also has a 2-speed rear driveline module. This one can be locked by driver request. Now the transfer gears and final driver is a single assembly, as you see here with the parking gear. And there's your PTO gear on the left. The PTU unit is nothing special. There's just a couple of gears in there that will activate or actually turn an output shaft going down to the rear differential. It has a conventional torque converter, nothing fancy or new here. It uses a single disc friction. It's actually splined to the dampener assembly. The cooling system has a bypass valve in it. The location may vary compared to make and model. The typical bypass allows fluid to pass through the cooler until it reaches the stops the flow until it reaches operating temperature, then it allows it to pass through. If this gets restricted, you'll still have lube oil going through the transmission, but obviously the transmission will overheat very quickly. Okay, the next several pages we'll be going through as the TSB that you see listed here, and this is for the Adaptive Learn procedure. It's very important that we follow these pages step by step. Obviously, we're not going to read through every page, but I just want to stress on the point that we do have to follow these pages step by step. So you can go through this at your leisure. Now, this Adaptive Learn procedure should be done anytime the valve body assembly or the transmission has been overhauled. Now, the adaptive memory cell is going to be cleared using either a OE software for a laptop called YTech or a capable scan tool. Now, this TSB, as well as others, can be found on a free website along with factory wire diagrams, and you have that website listed right there in your handout. Like I said, this website is free. It has quite a bit of information. It may not have all the vehicles you're looking for, but it's got quite a few vehicles with good information in there. Again, I want to stress on the fact that we have to follow these step by step. One of the things I want to point out here is we do not want the adaptive learn procedure confused with what they have, what's called a quick learn. The quick learn is soon going to be called valve body solenoid learn. This is nothing that we haven't dealt with before. This is something we talked intensively about in the 6R140s by Ford. If you buy a new solenoid block for a 6F50 or 6F35, there will be paperwork explaining that the solenoid body strategy has to be downloaded into the TCM. You'd have to flash the TCM when you replace the solenoid bodies. It's very similar to what we talked about earlier on the 8L90s by GM. It seems to be that all the transmissions are going this way. And I guess this is just the explanation of the learn procedures required to match the transmission control module electrical system with the solenoids on the valve body. Now, this procedure should only be performed when the valve body or transmission control module has been replaced. If we're rebuilding the transmission and reusing the solenoids, it's not necessary to do the valve body relearn. We do not want to perform a quick learn when the transmission assembly has been replaced. We do if we just did an overhaul in the transmission. Now, the quick learn or valve body solenoid learn will erase all factory settings when performed. It'll erase all the adapt memory cells as well. So if you've already done the adaptive learn and you turn around and do this quick learn, you have to still go back and do the adaptive learn also. So we don't want to perform the quick learn if all we need to do is the adaptation learn. That's what we're trying to stress here. And last but not least is the general specs that I came up with for the most of the Chrysler Jeeps that you'll find with this transmission. I'd like to say a special thanks to Robert Bateman over Seal Aftermarket Products for all his help in compiling this information and the pictures. I was lucky enough to go over there for a few days. We had a couple of different units from different models. We completely tore them down, took lots of pictures that will be used for future seminars, articles, and webinars as well. We got a lot of good information. We dissected everything in the transmission to see how it works. So it was a good time to learn a lot about this trans. Okay, today's presentation is sponsored by Seal Aftermarket Products and Toledo Transkit. If you have any questions, by all means, go and text them to me now. If not, I want to thank you all for attending. Hope I see you guys in the next couple of weeks for the next webinar. Thanks again.